on recording. Okay, part C. Remember, part B, we're just going to skip for right now. When you learn it, you're like, oh, that was easy. I promise, like that one is easy. So Ca+2. Calcium is a positive ion, correct? A water molecule that's drawn a big circle and two little ones. What's the big circle representing? Oxygen. So it has the partial negative charge, right? And this would represent the hydrogen. Partial positive. So Mickey's face should be touching Ca+2, not his ears. Or Minnie, if you're whatever. Oh, good point. Should look like that. Uh-oh. Jackson, what?
I was mad because I wrote it like that, and then I was like, no, you're wrong, you're wrong, you're wrong. And then I was like,
You did not write it yet. It was his own decision.
Mr. Burt and I, we have a song. Most people don't, they're not aware that we have a relationship that has a song, but we have a song and it's by Roxette and it's called Listen to Your Heart. Okay, not your lab partner. So, oh, okay. So, when in doubt, listen to your heart, unless you're wrong, and then don't. There's the motto for the day. Later. What? Yeah, we're tight. Any Roxette song is really our song. Okay, here we go. Next. These are all taken from previous AP tests. They may or may not be on your test. Here we go. Which of the following is the balanced net ionic equation for an oxidation reduction reaction between silver, or Ag+, and Ni solid based on the half reactions represented above? Shh. So much easier to do this if you don't talk while I'm talking. Okay, so you have these two half reactions. Now, we haven't maybe written it as a half reaction, but it's like the whole thing, it's just Ag plus Ni solid, whoops, goes to Ag plus Ni plus 2. Like it's just broken into two parts. I don't want to write more or I'll write the whole thing for you. So see if you can figure that one out in a second. Okay, do you need more time? Okay. All right, I got 2 thumbs up from the class barometer. Everyone else ready? It's actually a really fast question if you know how to answer it. All right, so should we raise hands? Who thinks it's A? We have 1. Who thinks it's B? We have none. Who thinks it's C? We have 1, 2, 3, 4. And who thinks it is D? Raise your hands. All right, the answer is D, as in Davidson's birthday is on Saturday. Now, D as in Davidson's birthday is Saturday. Right here is the key. Look right here. This has a change of 2 electrons, correct? This only has 1. They have to be equal, correct? So no matter what, you have to double everything here. So you find the one that has 2 Ag plus, which this did also, but it didn't have 2 Ag solid. You had to have them both. So when it asks about balancing in this unit, in chapter 19, like balancing redox is like a half a page, no joke. But for this unit, it's easy. Make sure that the electrons balance and then add everything together. So if we did add it together, we'd have 2 Ag plus Ni, I did that again, Ni solid plus 1 or 2 electrons, right? And then on the right side, we'd have Ni plus 2 electrons and plus 2 Ag solid. Now, that's not all written there. How come? Because the electrons, you had 2 on the left, 2 on the right, so we wouldn't write them. They'd cancel out. Okay. I think there's one more. This is a math one. This will take a little more time. Can you read it? It's a 0.02 liter, if you want me to save you some time. Sample of potassium carbonate is 0.03 liters of 0.4 molar BaNO32. Barium carbonate precipitates, sorry. The concentration of Ba plus 2 in the solution after the reaction is, so all this is asking for is the concentration of Ba plus 2. Okay, have at it. I'm going to pause this because this will take a few. All right, what? You can write all over the booklet. Okay, here we go. What's step number 1 here? Balance it. Okay, is anyone okay if I just do the net ionic? Why did I put NO3? I'm an idiot. Are we okay with that so far? What's nice about that reaction? It's all ones. Okay. Now, you don't have to do it this way. Did anyone make a table? No. It's okay. Whoa, those look like great lines. You're welcome, world. All right, you don't have to do it. I'm going to do it just to kind of reinforce how I did that. You okay with that? So what's my initial carbonate? I look over here and I have 0.02 times 0.2 is 0.004. Is that right? Okay, and there's only 1 carbonate per potassium carbonate. So carbonate's initial is 0.004. Okay, barium's initial is 0.03 times 0.4, and that's 0.1012. You okay with that? Okay, do I care here? Nope. Because it's only asking about barium, right? This must be the limiting reactant here. Or one of these would have been a 0 as an option. We can also tell math-wise because 0.004 is less than 0.012, and there's a 1-to-1 ratio. Okay, we all should know that at the end, the moles of limiting reactant are 0, right? So the change is negative 0.004. Since it's a 1-to-1 ratio, what's the change here? Negative 0.004, which means at the end, BA plus 2, I don't know, I was about to write that. At the end, it would be 0.008. Okay. Is everyone okay with that? If I was over here, I don't have to care, but let's pretend I do. At the start, there'd be 0 precipitate, right? At the end, since it's a 1 again, it would be a positive 0.004, correct? And the end would be 0.004. And to find the molar mass, I would multiply by whatever barium carbonate was, which I'm not forced to care about. So why would I? Okay, so really the question only cares about this. Is this the answer? No, I need to divide that by the total volume, 0.05. And what did we end up with? B. B is in birthday Friday. Genius. Saturday, actually. Did that help? Did it help answer your question? Not the math, but the moles. Did that help? Okay. You need to come and get help. All right. Okay, that was that. It's 0.05 volume.
Well, you got 0.2 and 0.4.
And point. That's your moles. All right. Let's call that good. Let's go back to the disaster I called practicing these things. Sound good? It was going pretty well. Might as well go back to it. I've done better. Oh. Oh, no. Good, awesome question. He said on the list of things to study, it said combustion analysis. Last year, I switched to a different book, and combustion analysis was this 4th chapter, but the book we're using again now it was the 3rd. We already did that, so you don't need to study it. So it will not be on the test. It will make the test a lot easier because you already failed that last time. Yeah, that wasn't very nice, was it? All right. I don't even remember where that was. It wasn't here. This question here is just the same as the other style where you had to make the electrons balance, if you wonder why I skipped it. You can look at it if you feel like, well, I looked this up. Okay, so we were on the sulfuric acid and potassium hydroxide equimolar solution, right? And it turns red. All right, here is why. So equal moles makes you, it's sort of a trick question. Equal moles makes you think, oh, I have equal moles because it says equal moles. But sulfuric acid is a diprotic acid. It means it gives off 2 hydrogens. H2SO4. So if I have 1 mole of H2SO4, how many moles of H plus do I have? 2 moles of H plus, because we multiply by the subscript, right? Who's with me right now? We've done that like on the precipitates and everything, right? Like that. Okay, but potassium, don't talk. Potassium hydroxide is KOH. When it dissociates, if I have 1 mole of it, how much OH do I get? 1 mole. So in this solution, I've made 1 mole of H2O and I have excess of 1 mole of H plus. That makes it acidic. and universal indicator is red in an acid. It's purple. It's dark purple. It can look blue, it can look black. Well, you're going to learn about indicators way more detail. No. We can talk about that. Do you understand the concept of that one though? Ignore the color, but why there is extra H plus. Thumbs up if you understand why there's extra H plus. Because for every mole, you get twice as many H's as you do for 1 mole of OHs here. Okay. All right, a solution containing silver 1 ions. This has got to be way old. There's so many mistakes, and only an idiot would say silver 1. And tell your partner why only an idiot would say silver 1. Because it's always a 1, right? Good old Tom. What was he thinking back when he was young and not fat? All right, so Ag plus, if it says 1 or whatever, that's its charge, but we know it is anyway. An oxidizing agent. Now that doesn't mean it's oxidized, it means it causes oxidation to happen. Is added to a solution of iron 2 ions. All right, a reducing agent. If the resulting solution was filtered, what would you expect to find in the filter? So we have Ag with something, we have iron with something. What are we going to get in the filter? Just silver. It's okay. Remember the chart, which you'll have in your test. Hopefully I have it somewhere. Right here. All right. So since silver is down here, it's more likely to form a solid than something above it. Okay, so silver will come out. Now, the way that problem is written, it's tricky. There's not enough to write it out. So I'm not going to worry about it. But the concept, the things that are lower will become solids. They will not stay as ions. You all right with that? So it's tricky. I don't know who wrote this. This guy was drunk. Yeah, I know. Actually, I know who did this picture. This was Jaron McKee. He drew that picture one day. It was on this screen, and he walked in and started to decorate my face. Because who doesn't want to decorate Davidson's face? Like on a screen, not face to face. That's awkward. A guy today, I got my MRI, and he like cleaned me. It was really awkward, just being touched. It's like, what is going on? There's like a paintbrush. But that dude was like Kobe. He was like 10 feet away, and all three of them, he'd like, what? And then he like 10 feet away, buckets every single time. The soap, the iodine, and the alcohol. I was impressed with him. Okay, moving on. You don't even care. Thank you. A small piece of rubidium is added to water. So what will we have on the right side? And would it be aqueous or a liquid or a solid or a gas? What do you think? Why? It's a strong base. Why is it a strong base? Because it's in family 1 hydroxide land, right? Amazing. Okay. What else would it make? What's left? Oh, an H. H2 gas. Would it be endo or exothermic? It's extremely exothermic. It blows up on contact. I can't own this, but alkalis in water explode. Like lithium's weak, sodium's pretty interesting. Potassium's really cool. And you will see them. You will. I haven't shown them yet. But yeah, we do it in chapter 7.
Will we like actually put it in
No,
water?
I will.
You will?
Yeah, right here. You can see evidence of it on the ceiling if you look close. What yellow thing on the wall? No, that's the holes in the ceiling. No, I have a big clear thing that I put up that's burned, so it's actually filthy, but I have a blast shield. Okay, so it'd be exothermic. Next, potassium carbonate, K2CO3 solid is added to hydrofluoric acid, HF. I need to know what goes in this bracket. And L, good. All right, just like the juniors, sophomores in dodgeball, they're taking the L. I know that was the funniest comment I've ever put on the group me that no one understood. So Miles Ferry, we're in the student government group me, and they're talking about forming a dodgeball for each individual grade. And he's like, the juniors will wreck. And he spelled it R-E-C-K, right? Or something like that. And even though I'm talking about Seth, no, he has no idea. Okay. And he said it like twice, R-E-C-K. And I'm like, Miles, one of those words is missing a W, just like your team will be, or something like that. But anyway. Yeah, I think 2 people got it. You liked it out of like scared. You're like, I better like it. Oh, wait, can someone tell me why this is an L? It's not a strong acid. Not a strong acid. So I got a question. What will be the spectator ion? There will not be one. If you don't have an aqueous on the reactant side, even if everything on the right side with aqueous, you still wouldn't have a spectator because it has to be aqueous on both sides of the arrow. So we would end up with H. Oh, what would we end up with? H 2 O plus CO2 plus why was that weird? That was the Mario jumping onto the flag. After like 25 years, I sort of remember that noise. I think I screwed it up though. It's like something like that. It's been a long time, like 1986.
Yeah.
Big brain. Okay, red flag, right? I feel that this went super well and you'll do perfectly on your exam. Or I actually feel like it didn't go very well. So let me pick one from your exam and we'll do it together.
Yeah.
Deal. I'm so down with that.
Deal? All right.
Watch me fail.
I won't. That'd be awkward.
That would be really sad.
Chapter 4, free response 2021, easy, coming right at you. Okay. Okay, here we go. This is letter A from problem number 4 on the actual exam I will give you. And I don't plan to change it. Do you understand the words coming out of my mouth?
Yes.
All right, I'm going to sit back here and wonder where Keely went. All right. How about it? Are the bottom of my shoes gross or something? That's always awkward. What's mean about it? Well, you have a lone element. What does that mean? Yep, he's not just a good looking face, girls. He is a smarty. Who gets bullied because he has diabetes. The sadness ensues. All right. Well, there we go. Well, no one's going to watch it. The only two bodies not here are not going to watch it. Okay. How was that? Scale of 1 to 5, 5 being I could never, ever, ever do that again. And 1 being I could do that with 2 eyes closed and 1 hand. Okay, ready to raise your hands. No one wants to do it without eyes open. Okay. 5. Okay. All right. Well, that was fun for me. You okay with that? Thank you. All right. I want to do something right here, right. Here we go. Hey, I feel like all the answers are right here. There we go. Solid aluminum is added to silver nitrate. Right? And balance the reaction. Indicate which element is oxidized and which is reduced. So that's what we just did, just a little bit harder. I don't know, maybe easier. It depends on you. Show the transfer electron using brackets. Explain how balancing the reaction helps explain the overall oxidation reaction. What do I even mean there? Oh, I'm waiting.
I literally just did this.
Thank you for all the blessings. We just went over that. It's +1. Silver's always a 1.
Okay, I get it mixed up with the one that's always +2.
Can I tell you what my high school teacher taught me about silver? Sort of not very nice. He said, if you propose and you give her silver, she'll give you 1 finger. I don't know if that helps. Oh, I did? My bad. But I've never forgotten it. I've never forgotten. Silver's a 1. It's not a very nice one. But she expects gold with diamonds. Silver's great, but good luck. A marriage built upon silver does not survive. Platinum's great. Now, that was recording. Yeah. We're answering number 3A. Just fuzz it. All right. In a minute and 30 seconds, the bell ringeth. So I'm going to pull this down. So I got Al plus AgNO3 goes to Ag plus AlNO33. Who had that part?
Oh, I think that was
Good. All right. Ag gained. Ag becomes a solid because it's at the bottom of the oxidation thing, right? Right, this chart. Silver's way down here, so it will be the one that becomes solid. All right. If it becomes solid, it's also the one that was reduced. So aluminum lost, silver was reduced, yada, yada, yada. All right. Tomorrow we'll review more. Thursday, you'll take a test and have fun. Tomorrow, I'm going to give you a little quiz. We're going to talk about something. It won't be under grade. Then we're going to quiz it and make sure you're good. It's on titrations.
Oh, yeah, I don't.
Yeah.